folks, welcome back to yet another episode of Blackboard Math and Physics. So today we're going to be taking a look at a classic elevator problem. So this one's pretty interesting. So where am I? So I'm right here, so make sure you can follow what I'm doing. So let's say you're in okay, so let's say you're in an elevator and you're standing on top of a spring. So here's the spring and here's where you're standing. All right, so let's first begin with the simplest scenario, that the elevator is at rest and you're not moving, you're on the ground floor. What's happening? All right, well, something's pretty interesting happening right here in the spring. The spring, two forces are acting on the spring, even though it's not moving. And as a matter of fact, that's why it's not moving, because there's two forces acting on it. There's the force of you pushing down on the spring with all of your weight, mg, but there's also the force of the bottom of the elevator pushing back up with a force equal in magnitude but opposite in direction, mg. So you might have never have thought of this, but actually that's exactly what happens in all springs, right? When you have a spring attached to a wall, that's the exact same scenario, right? You have a spring attached to a wall and you pull on this side of the spring with 3 newtons. The wall is pushing back with 3 newtons. The wall is almost like a person grabbing the spring so that the other end doesn't move. We just don't focus on that part because this is the part that's actually moving. That's the part we're concerned with. So with that being said, let's say the elevator now begins accelerating. Let's say it's accelerating upwards. How about that? Okay, well, if it's accelerating upwards, what can we say? What are the forces acting on the box, on you? Well, first and foremost, we can write your weight, right? The weight you feel. And we can write that as W. Okay, now subtracting from your weight, since you're accelerating upwards, what does that mean? Well, that means the net force acting on you has to be upwards, right? If the net force acting on you has to be upwards, that means your normal force has to be greater than your gravitational force, meaning that you probably feel heavier. So what does that translate into for us? Well, we can say that we can apply Newton's second laws into you. So we can say W minus mg is equal to the force acting on you. But we know the force acting on you is also equal to your mass times your acceleration. And so the weight you feel when the elevator is accelerating upwards is simply your mass times the acceleration you feel due to gravity plus the acceleration of the elevator itself. So this right here, this formula right here is going to give you the acceleration you feel when the elevator is going up. How about when the elevator is going down? Well, it's pretty much the same scenario, except now you're going to feel lighter, right? So when the elevator is accelerating downwards, the acceleration you're going to feel, the weight you're going to feel is going to be not a plus g times m, but a minus g times m. So we're going to have what? The weight you feel is going to be m times g minus a, and that's the weight, the apparent weight you're going to feel when the elevator is accelerating downwards. Now you know that in an actual elevator, when you go up to a higher floor, in the beginning you start accelerating up, but near the top of the floor you start slowing down. So in the beginning you're accelerating upwards, you're feeling heavier, but when you start approaching the floor you want to go to, you start decelerating, you start feeling a bit lighter. And so when you feel lighter, you actually feel kind of weightless or less weight than you actually would have. So that's how you derive the formulas for your weight in an accelerating elevator, and we'll check you out in the next lecture of Blackboard Math and Physics.
Embedded plus MKO plus scaffolding equals learning. We believe anyone can learn anything. That's why our motto is memorization is a crime. And that's why we partnered with Brilliant.
Brilliant transforms math and science into hands-on activities so that you too can understand everything from first grade math to E equals mc squared. Barry Science Lab and Brilliant is your MKO, and will give you the scaffolding to expand your ZPD until you become the next Sir Isaac Newton or Albert Einstein.
Visit brilliant.org/Barry Science Lab today. And the first 50 of you to use that link will get a 20% discount on the Brilliant annual subscription.
Don't forget that you too can become the next Einstein. So let's fall in love with math and science.